And thanks for the introduction. And hi, everybody. My name is Han. I'm a research associate at University College London. And this is a work I did in collaboration with my PhD supervisors, Olivier Chapuis, Michel Beaudouin-Lafon, Eric Lecolinet. They are based in Paris. Today the topic is about a set of cooperative gestures to support collaboration on wall-size displays. Large wall-size display provide an interactive surface for users to interact with large data sets. It has great potential to support collaborative exploration of these data sets. By having multiple users physically navigate in the data by walking around in front of it and interact with the data and between each other concurrently. The literature shows that arranging data spatially can help us with sense-making. And it helps us to generate insights such as looking for patterns, variations, differences, and so on. But standard multi-touch gestures are not really made for this environment. You can see it takes very long drags and very inaccurate swipes. And the gorilla effect, well, people holding their arms in the air, makes it very, very tiring to work with this platform. And also, there is no consideration of supporting collaborative operations with the traditional gestures. So now the question is, can we redesign the gestures for this platform, considering both the large scale of the interaction and also the support for collaboration? The idea here is to provide interaction techniques where multiple users collaborate for single operations. We call them shared interaction techniques. And a few existing techniques have explored this concept on tabletop surfaces, on cross-device interfaces, but it hasn't been really explored in the context of wall-sized displays. And also there has been very little understanding about how they are used in the actual collaborative tasks. To fill this gap, we present CoReach. It's a set of cooperative gestures for supporting arranging data on wall-sized displays. To get some inspiration for the design, we started with an observational study. We observed how people move around paper cards in a collaborative task. We recruited 4 pairs of participants, and they were given a set of ambiguous images, as you can see here, from a game called Dixit, and they were instructed to extract similar concepts across the images, and so they can group them or arrange them to tell a story. It was interesting to see in a large scale like this how the participants were taking advantage of the space to arrange things spatially to help with their task, while coping with the distance. Then the question is, how to help them? We came up with our design guidelines from the study. We observed that they frequently showed things to each other and sometimes exchanged objects, but they kept going back and forth and follow each other to cope with the distance. So for a long while, it gets really tired. We want to support these operations at any distance with our technique. We also realized how fast the dynamics of collaboration changes. So their exchange was really on the fly during the discussion, and they changed from working on their own and working together really constantly, sometimes even subconsciously. So there's almost no time to trigger a menu or switch a mode and to trigger some cooperative operation. And the last thing is that they sometimes carried a stack of images when they are walking around in case they need it. So apparently a temporary storage could be needed in this case, but they need to be accessed easily anywhere when they are doing the task. With those guidelines in mind, we came up with 3 cooperative gestures, and they are designed for pairs. Although group work involves multiple users working at the same time, but we suppose individual collaborative actions most frequently happen between 2 people, such as I give you something. And especially in the task like when they are exploring a data set, for example. Now let's go through the techniques one by one. Preview is a technique to allow one user to show something to another user at any distance. It is triggered by both users performing a touch and hold with 5 fingers on the surface. When preview is triggered, it creates a temporary copy under the hand of the user 2. Oh, sorry. And after 10 seconds of no interaction, the copy disappears. Or before it disappears, the user 2 could double tap the copy. It will catch the real object and it flies over. So it supports the data transfer during discussion and negotiation. Throw and catch. It literally enables one user to throw something to another user, and the other user can catch it with a double tap. Like this. After being thrown, the object blinks for 10 seconds if no interaction, and then it would stop blinking. While it's blinking, it can be caught by another user, and the object flies to the position of the second gesture. To reduce false positive, we distinguish the direction of the gesture for the catch area. An object being swiped to the right can only be caught at the right side of the swipe position. But it doesn't need to be at the right side of the object landing position. So it provides a very flexible way of catching objects. Some users were throwing it over and then sometimes even catch back by themselves. So the accuracy of swiping is not important at all with this technique. Shared clipboard. It provides a temporary storage where both users can add and remove items for it, and it can be accessed anywhere by any of them at any time. So objects can be added and removed to the virtual clipboard by a whole hand tap, and they are highlighted after being added and can be collected as a cluster at any position. So here it actually creates a selection mode. And to release the group, the user needs to perform a zigzag gesture. Okay, so the 3 CoReach gestures support different collaborative actions, which requires different synchronization level between the actions of the 2 users. Preview requires concurrent touch and hold, and throw and catch has a 10 seconds tolerance between the 2 actions, and shared clipboard does not require any synchronized action, but you need to be aware of what has been selected and what is the group about and so on. So they all support moving objects, but in different collaborative scenarios. We want users to be able to walk around freely in front of the display instead of having to be in contact with the display all the time. Therefore, CoReach gestures are extended to multiple surfaces. It works across the wall and multiple tablets via something I call remote touch. We project the touch from the tablet to a proxy on the wall, like this. And dragging with one finger moves the proxy, and dragging with two fingers would move the data under the proxy. We kept the gestures pretty much the same on the tablet and on the wall. And when preview is performed on the tablet, the copy also shows on the tablet. But however, in the user study, we find out people rarely looked at the tablet. And we can see the gestures be performed between the wall and the tablet, and between tablet and tablet. To understand the effect of CoReach gestures, we conducted 2 exploratory user studies with 6 pairs of participants each, using a very similar task, collaborative task to the one from the observational study. Participants were asked to group the ambiguous images by extracting common concepts. The first study compares standard gestures with and without adding the CoReach gestures in the gesture set. In order to test the gesture acceptance, it happened only on the wall. And while the second study compares the use of CoReach gestures across multiple surfaces. So due to the time constraint, I will not go into much detail of the study design, but highlight a few insights. CoReach gestures were frequently used during the study. In average, 30% of all gesture actions in the CoReach condition were used to compose CoReach gestures. The rest are dragging or other individual gestures. And participants found it fun to use, collaborative, and however, different pairs of participants used different gesture more frequently than others, depending on the strategy they used, and sometimes also it depends on the relationship between the participants. We found that adding CoReach gestures reduced the physical effort. As you can see on the graph, comparing standard gesture versus adding CoReach gestures, they significantly reduced the overall length of dragging effort for achieving the same amount of object movement. And this is echoed in the subjective ratings from participants for the physical fatigue. As another finding, some participants mentioned that being able to catch objects anywhere on the surface improved the accuracy of placement of objects. In the physical world, we might assume that people are less collaborative when they are far away from each other. But here, CoReach gesture facilitated the collaboration in distance. Here, as one of the participants said, with CoReach gesture, presenting the idea of a group of images to my collaborator is more interesting because I know he could throw me some images I might be looking for instantly. And with the quantitative measures also showed the average distance between the 2 actions performed for preview and through and catch gestures are around 3 meters in average, which is half of the width of the wall. It is worth highlighting that through and catch was the most preferred technique on the wall, probably because of its 10 seconds tolerance of the synchronization, and also if one of them decide to not collaborate for that action, they just forget about it and they will stop blinking. Moreover, users appropriated this technique for using them alone to save effort or to increase accuracy for the action, and occasionally they also used it for negotiation by throwing over and get it back. In the beginning, we thought extending the interaction onto tablets are going to be powerful and users are going to love it, but it turns out more than half of the participants preferred to use the wall only. And the tablet usage has very large variances across groups, pairs of participants, between 0% to 50%. And part of the reason was explained by one of the participants. He said, I couldn't collaborate with my partner when we were not on the same device because I cannot see what she is doing, I cannot relate to her action and her motivation. So apparently, the wall alone condition made the actions more transparent, so people felt like they can collaborate better with only performing the gesture on the wall. However, some other participants really liked the flexibility provided by the tablets, so they can mix different strategies and divide the work differently in new ways. For example, here it's one of the creative strategy used by the participants. And in this video, these two participants were looking for images that belong to one group. And we can see one of them put his proxy at a fixed position and only used the tablet to catch objects. So they were both swiping and throwing the objects, and only him was catching all the objects into the same position. So this was very efficient because it saved the effort of them to going back to the group position all the time after finding an item. To summarize, CoReach gestures support collaborative data manipulation, particular arrangement, in the lightweight way, and because it doesn't require calling for menus or switching mode to trigger the collaborative actions. And they support different synchronization, therefore it fits in the collaboration dynamics for tasks like sense-making, exploring a data set. And they help reduce the physical fatigue by saving the dragging and walking distances. And the last but not least, the remote touch, although affected some of the transparency of action, but it supported the flexibility and allowed users to use different strategies and allow them to divide the labor differently. As future work, as you might think, well, this kind of actions would require a lot of coordination. We thought about that too, but with our questionnaire, it did not suggest that in the CoReach condition, people felt there was more coordination effort. I guess the reason was in the collaborative task, coordination is essential in any case, no matter you made the gesture cooperative or not. But they did need some coordination support in the way where when they are far away from each other and one of them started a CoReach gesture, the other might not know which gesture the person started. So they need a kind of oral protocol or a way to communicate that when they are far away. And of course, the next thing is about the scalability and also the increasing challenge of false positive when there are more users using the technique. So I have some discussions in the paper. I will not go into detail here. With that, I will thank you and welcome your questions.
Hi, Raimund Axelt, Interactive Media Lab Dresden. Very nice work, and it's a great space to explore. I think there's a lot to do still. I just slightly disagree with your statement that it is applicable to a wide range of applications. I think it's not true, actually, because even if you say it's about layouting stuff or working with several elements, for example, if you think about a layout task, collaborative layout task, where you have to have a precise layout or so, it's a completely different thing, and some of your gestures would not really apply to that pretty well. So I think you should maybe be a bit more careful about the generalization as far as applications go, and maybe in concern with that same thing is the gestures. Don't you think if you have a more complex application that you also have some more other tasks, like local tasks where you need more gestures, and how do you think match the gestures you invented basically with the other gestures? So don't they conflict? Or so this is a question I would have. So how do you make a consistent set of gestures, also considering application-specific gestures in a more complicated application than you have shown to us?
Okay, thanks for the question. That's a very good